So last class we discussed about interference part. So now I want to analyze the Young's double slit experiment. Young's double slit experiment. Double slit experiment. Young's double slit experiment is the experiment. Right. Thomas Young is the scientist. He discussed about interference with wave nature experimentally. Interference means, already I said with you, a superimposition of two or more than two waves. But in Thomas Young experiment, he used the coherent sources. What is mean by coherent sources? Two sources are said to be coherent. They must having same frequency, constant phase difference, amplitude may or may not be equal. Once again, same frequency, same angular velocity, constant phase difference. Very, very important point is two independent sources never be coherent. That means two headlights of a car, two tube lights fitted in a room never be coherent, because out of these three conditions, any one condition is going to be failed. Sir, how to get coherent sources? Coherent sources is obtained from a single source. So first one I am analyzing with you, that is YDSC experiment. Sir, Thomas Young did like this. He taken two cardboards that are like this. S is the pinhole made by the Young to the cardboard. S1 and S2 are also two pinholes equidistant from S. S1 and S2 are two pinholes equidistant from S. That means SS1 equal to SS2. This light source, this pinhole is exposed to the sunlight. Previous he did experiment with sunlight. How we modified that I will discuss with you. Sunlight come from source is like this, in the form of waves, crust and troughs, like this. The light come from single source S is divided into two parts, two wave fronts. I think so you can understand. Interference of YDSC experiment is concerned to division of wave front. Like this, crust and troughs is divided like this. This is the screen. Two light waves come from S1 and S2 is superposed in such a way that there is alternate bright and dark bands are observed on the screen. When it is bright, when it is dark, you may get it out like this. That is two troughs. This is the wave nature. Crust, trough. And this is one more crust and trough. Crust, trough superposition causes the rise in amplitude is 2A. C plus C, 2C. T plus T means 2T. Or you can say like this, amplitude is A and this is also A. Then I am going to get 2A is the maximum and 2A. Crust superposition, trough superposition gives maximum intensity. that is 4a square of amplitude is called maximum intensity breakband. So here it is trough and trough superposed breakband. Next, if I think about like this, another crust. Here crust and trough superposed, what I am going to get? Dark band. What is the reason for getting of crust and trough dark? Crust and trough superposed, a minus a whole square, that is minimum equal to 0. It is perfect dark band. I am going to get superimposition of crust and trough. Clear, I think so, sir. Next, here you observe it. Crust and crust superposed. Once again, bright band is formed. In this way, whole screen is formed, bright and dark band successively on the screen. Right. Sir, okay. This is the experiment explained by that of Thomas Edison. Used cardboards, sunlight is used as a source, and two pinholes are created like this. Present days, sir, we modified like this. What is that? Sunlight is replaced by monochromatic light and laser beam. Monochromatic means single color, single wavelength. Laser light. Next, pinholes is replaced by slits. We are improved. The experiment is like this. Next, sir, my task is this. Okay, bright and bright form. What is the distance between bright and bright dark and dark? Bright and bright, dark and dark distance is called fringe width. Successive bright band distance or successive dark band distance is called fringe width. So I want to calculate fringe width expression. Fringe width Before going to the fringe width, I want to think about intensity maxima and minima. Here, sir, we are utilizing the sources of same amplitude because the same wavefront is divided into two parts. Intensity, previous I said with you, A1 square plus A2 square plus 2A1A2 cos delta phi, phase difference between the two. Right. Now that it is I equal to A square plus 2A square cos phi. Phi delta phi or phi is the thing but phase difference. 2A square into 1 plus cos phi. I think so you know about this. 1 plus cos theta is 2 cos square theta by 2. 1 plus cos 2 theta equal to 2 cos square theta. Now that is 4A square cos square phi by 2 is the maximum intensity of the two coherent sources intensity. Maximum is cos square phi by 2 equal to 1, cos phi by 2 equal to plus or minus 1. I think so you know about this. Condition for plus or minus 1 of cos term, cos n pi. That is pi by 2 equal to n pi equal to 2n pi. Third bright band 6 pi phase angle. Fifth bright band 10 pi. Simple bits you will find it. You may get it out like this. Delta x, path difference, maximum. Delta phi equal to 2 pi by lambda into delta x. That is 2n pi is equal to 2 pi by lambda into delta x. 2 pi gets cancelled. Delta x equal to n lambda. Condition for maximum. Path difference. Third bright band maxima. 3 lambda. Fifth bright band maxima 5 lambda. Path difference. Next, sir. So what is that intensity maximum? I max equal to, just now I said with you, cos square pi by 2 is 1. I max is 4a square. This we call it as constructive interference, where the two crust and crust, trough and trough are superposed. Then it gives constructive interference of maximum intensity 4a square. Minimum is I minimum equal to 0 and cos square pi by 2 is equal to 0. Cos square pi by 2 equal to 0. That is phi equal to odd multiples of pi by 2. 2n minus 1 into pi by 2. 2n minus 1 into pi cell. 2n minus 1 into pi by 2 gives minimum. Of pi by 2 surfaces, pi by 2 gets cancelled, 2 gets cancelled. Phi equal to 2n minus 1 into pi gives the condition for minimum phase angle. Third bright band 6 pi you land. Third dark band, if they ask us, 2 into 3 6 minus 1 5 pi is the minimum. If it is path difference, simple, pi is replaced by lambda by 2. 2n minus 1 into lambda by 2 gives minimum. This is a minimum phase angle. This is a minimum phase difference. Okay, sir, this is the way to apply the condition of intensity condition. Next, what about fringe width? Sir, if without knowing this, I can't calculate the fringe width maximum and minimum condition. Let us suppose S1, S2 are equidistant from S. That means path difference XY is the screen. O is the center of the screen. Distance between the slits and screen is capital D. Distance between the slits and screen is capital D. And distance between the two slits is small d. Small d. Distance between the two slits is small d. Try to understand me. This is small d. Sir, I want to calculate distance of nth band. Distance of nth band from center. Distance of nth band from distance. O sir, by n. How to get this? For this, I have to know the path difference. Delta x I have to know. In YDSC experiment, first step should be you have to calculate path difference amount to get anything. So, path difference. This is the condition. Delta x equal to path difference. Delta x equal to S2p minus S1p. Sir, why you are not starting from S? SS1, SS2 are equal distance, no? They cancel each other. If it is not equal, then I have to start from S. Take care once again, please. SS1, SS2 are equidistant. That's why I am not starting from S. Otherwise, if they are not equal distance, I have to start from S only. That I will discuss with you further classes, further part. Now, here, sir, drop a normal to the longer line. Then S to N plus NP minus S1P. I think so you can understand. Between two inclined lines, after intersections when they have small angle, these two are equal. That is S1P equal to NP. S1P equal to NP. Then these two are cancelled. Delta x equal to S to N. Path difference. Then I think so you can understand. This is theta. Opposite side I want to calculate. Delta x equal to d sin theta gives the condition for path difference. Path difference. If you ask me phase difference, I am ready to calculate. Delta pi equal to 2 pi by lambda into delta x. 2 pi by lambda into delta x is what? D sin theta. Next one. This is delta x. Sir, what do you want to calculate? Nth breakband distance. Nth breakband distance. Nth breakband distance. Just now I said with you, condition for maxima is what? N lambda path difference. N lambda equal to d sin theta. Theta small. Sin theta can be written as theta. Sin theta can be written as theta. That is equal to tan theta equal to theta sin. Now that is d into tan theta. Tan theta we can write like this. If I draw like this, this is also theta. Tan theta equal to d into yn by capital D. Opposite side by adjacent side. Opposite side by adjacent side. So now that is nth breakband equal to n lambda dy by small d. I think so you can understand. N lambda dy by small d. N takes values 0, 1, 2, 3, so on. N takes values 0, 1, 2, 3, so on. That means central band is bright. Central band is bright. So this is about nth breakband distance. They ask us like this. They ask us like this. Third breakband distance, 3 lambda d by small d. Fifth breakband distance, 5 lambda d by small d. Okay. Sir, what they can ask you? Fringe width. Hi viewers, take care about it. I will move right to left. Right to left, not left to right, please. Right. Nth breakband distance, yn equal to n lambda d by small d. Just now I got n values already set with you. N takes values 0, 1, 2, 3, so on like this. For example, this is like this. S1, S2. Equidistance from the source. No path difference. Delta x 0. Delta phi 0. It is breakband. Breakband. Suppose if it is like this. This normal. S to n. S to n is lambda by 2. Lambda by 2. Then I am going to get minima here. Dark band. If it is S to n is lambda, path difference is lambda, I am going to get bright here, max. Here dark. Okay, no sir? Path difference 0, bright band. Lambda by 2, dark band. Lambda, bright band. Next I am thinking like this. Okay. Fringe width. Fringe width is distance between two successive bright bands is called fringe width. Any successive bands. For example, that is central band is 0, dark followed with bright. This is distance I want. 0. This is what? Lambda d by small d. Any successive bands. 0, 1, 2, 3 submitted. Any successive. So fringe width beta equal to lambda capital D by small d minus 0. Fringe width equal to lambda capital D by small d. That means fringe width is directly proportional to wavelength of source used, directly proportional to separation between the slits and screen, and inversely proportional to gap between the two slits. Gap between the slits is small. Fringes are apart. We can visualize, we can observe it clearly. Next, you may get it out like this. If we use from red to violet colors instead of monochromatic light only. First I use red, then like that up to violet. What about fringe width? Fringe width decreases because of decrease in wavelength. Right sir. Next you may get it out like this. What about dark band sir? Dark condition. Just now I calculated like this. Delta x equal to d sin theta, that is equal to d tan theta. d tan theta. That very important, sir. Path difference I said with you first step it should be. Next, that is equal to 2n minus 1 into lambda by 2 gives condition for dark or minimum d into yn by capital D. Tan theta. Just now I said with you from the previous triangle. Yn equal to 2n minus 1 into lambda d by 2d gives condition for minimum of nth dark band. Nth dark band, here n takes values 0, 1, 2, 3, so on like this. Like this. Next, sir, you may get it out like this. Here, sir, 0 we don't get, please. Why you are not getting 0? Why you wrote 0, you may get it. If I take 0, I am getting minus. It's not possible. 0 already fixed, sir. Observe it. 0 is fixed for bright band. What about here? Here is dark is not possible. From 1 it starts. Now that is first dark band lambda d by 2d, exactly middle of this. Exactly middle of this. Second dark band 3 lambda d by 2d. 3 lambda d by 2d. Next, fringe width, any successive lambda d by small d. So the conclusion of this is, so from this conclusion is like this. Fringe width between two successive bright bands are, that indicates us bright band and dark bands are equispaced. Bright and dark bands are equispaced. So you can understand very clearly. Bright and dark bands are equispaced. That means interference pattern is equispaced. Expression for fringe width we got it. Beta equal to lambda d by small d. Beta equal to lambda d by small d. Right, sir. Next, angular fringe width. Angular fringe width between two bright bands. Angular fringe width, theta, sir. Theta equal to arc length by radius, that is b by capital D. This is capital D. This beta by capital D gives theta. That is